cotton. At the front of that we've got the feeder, which is the conveyor belt, and then it's into the structure, which is 3 spike beaters. They spin around 750 times a minute and beat out any large pieces of cotton. So the cotton looks pretty clean. If Tom goes underneath and shows you a sample of what we're beating out of it, that's called trash, but that wouldn't be thrown away. That would have been sold on to someone who'd use that for stuffing things. So mattresses, furniture, and even soft toys. The cotton fibres up to the front of the machine. What the machine makes is a sheet. Most of the machinery in here are well over 100 years old, so wherever your machine made, you've got to pick it up and you've got to carry it to the next one. So to make it easy, the machine rolls it up, put metal rod through the middle, and we're making one of these. This is called a lap, and it's a rolled up sheet of cotton fibre. And there's one on the back of the next machine. We don't put this on for demonstration. It was in a place in the factory called the blowing room. You could have had 4 or 6 of those. The atmosphere in that room was full of cotton fibre and dust. So if you breathed that in long enough, it would give you a disease called bisonosis, which gradually the cotton fibres would rot away in your lungs. So not a very healthy place to work. But in the factory, someone picks up the lap, carries it to the next machine in the process, which is this one. So if you move to the front of the machine, what we're going to do now is carding, which is separating the long and short fibres. We're going to do some different things. There's a cylinder in the middle with spikes, notes on the top with spikes. The long fibres go to the cylinder, the short fibres are thrown upwards and picked up on the top. So if we have a look at the front of the machine, we can see the short fibres are coming off at the top. So you can see knots, bits of sea casing. You wouldn't want clothing made from that. In a factory though, they can make tons of it. So that's sold again onto someone who would make shoddy goods. So things like dusters, dishcloths, mopeds. It's also used in paper making. The biggest use for that today is actually strengthening banknotes. So a banknote isn't just made of paper, it's made of cotton waste and linen as well. At the bottom, all the long fibres being coiled up. We've got to pick it up and move it again, so we can press it between rollers and we coil it into a can. Okay, so what we've made now is something called a sliver. It's a soft rope of cotton. If we pull it, open it up, we can see all the fibres are all tangled up and crisscrossed. So it's quite rough. So to make a nice smooth thread, we need to make a nice smooth sliver. So we'll do that on the next machine. You want to move down a bit more. So how we do that is by blending lots of them together. So these are blending frames or draw frames, 6 sliders into the back, passing through 4 pairs of rollers, and 1 comes out at the front. What's actually happening, 4 pairs of rollers, called drafting rollers, from the back to the front, each pair's moving just that little bit faster. So as your fibres go under, they get a tug from the roller in front. So they slide. They get a next tug and they slide again. They get another tug and they slide again. So gradually reducing your 6 down to 1 and pulling all your fibres in the same direction. Do it once, that one is 6 times more than regular. Blend 6 of those, it's 36 times. And if you do it for a 3rd time, you get a finished sliver that's 216 times more than regular. Tom will put that one on for us. Not very exciting, but doing an important job. Okay, what have we made? We've made another sliver. Now it looks just like the last one. But pull the top off this one, open it up, and all your fibres are now neatly in the same direction. So it means we can make a much smoother, better quality thread. We've got to start making that thinner. We've also now got to make that stronger. There's nothing holding that together anymore. The easiest way, the quickest way, the only way to do that is to twist it. So we're tightening the fibres together. Put a bit of friction in there, and suddenly it's unbreakable. Now in a way that's all that holds your cotton clothing together. The fact that cotton fibres are twisted. Take all the twist out, give it just a gentle tug, and it all falls apart again. So we're going to start making it thinner and stronger, and we're going to do it on these machines. So if you go round the top. Okay, so these are the next machines in the process. These are called spin frames. So this is the first one we use. So take your cans of slicer, put them at the back. Again, we're going to pass it through sets of grafting rollers, so it's coming out thinner. At this stage, we've got to start putting in that little bit of twist. So we do that by pressing it down a metal arm called a flyer. When the machine operates and they spin, we get a little bit of twist at the top, and it wraps it on a bobbin at the bottom. It's easy to carry again. When the bobbins are full, take them to the next speed frame, put them in the rack, and this time take 2 of them. So 2 pass through a grafting roller, they draw out into one finer, another twist, and wrap it on the bottom. What we've made in those 2 processes is that. So we've reduced our sliver right down to something called a roving, and that's ready for spinning into thread. Now these 2 machines have been cut down to fit in the gallery. You could have up to 50 of these down one side of what's called the cardigan, along with your draw frames and your cardigan engines. Tom's got a photograph of a typical car route from around about 1950. You can see draw frames in the foreground, these speed frames in the background. Every machine then operated with a belt like ours. Our belt goes up to an electric motor. In the factory, that would go to your drive shaft, which went the width of your groove across your ceiling, and then down your steam engine or water wheel, whatever your power source. If your belt snaps, that's a danger in itself. If it happens to us, sit down for half an hour, put some nice smooth stitch in it. In a factory, they didn't have that luxury. You can't stop the machine. So they're not going to repair the belt wards. So you can imagine maybe 100 fast-moving belts, lots of metal studs, much closer together than ours. Eventually somebody's going to get caught on that. If you're lucky, get your sleeve torn. Very unlucky, it can actually be dragged off feet. And we do have documented evidence from factories of people being taken over lamp shafting. They didn't usually survive that. Especially in the days when children worked in factories. Now, you're a little bit too young, but at one time, children as young as 5 years old, along the bottom, if they were an old child and tall enough, so pretty simple. The problem is they'd do that while the machine was working. So they're not going to stop the machine to have it. You would have worked with. So that's why people who worked in factories. So what we've made on that machine, bobbins and roving, this was a factory, they go up to the spinning room. And we've got a spinning machine round the corner. If you want to come round this way, okay, this is our spinning machine, and it's got an unusual name. It's called a spinning mule. It's called a mule for the simple fact that, like the animal, it's a cross between 2 other things. It was invented in 1779 by Malcolm Bolton called Samuel Crompton. He borrowed 2 ideas. He borrowed the idea of the rollers from Outright's water frame, the inclined spindles from Harvey Spin and Jenny, put the 2 ideas together and built his mule around. Again, this has been cut down. We've got 137 spindles. Full size, this machine had 1,100. So you can imagine how big this machine was. And if this was a spinning room where you're standing, there'd be another one down on this level and facing in this. Working with them, 2 people called piecers, maybe a lady, perhaps a young lad. Their job along with the spinner was to piece up or fix any broken threads. Now when the machine operates, the spindles are on a carriage. This carriage rolls all the way out, stops and goes all the way up again. That's how it spins your thread. You will get threads that will break, but again, So they would spend their working day walking backwards and forwards, in and out, following the carriages and piecing up the broken